Good afternoon, everyone. Welcome to 11th week of discussion session of the course Plates and Cells offered by NPTEL. Course instructor of this course is Professor Sudeep Talukdar, and I am your teaching assistant. I am Asif Raza. I am a PhD scholar from Department of Civil Engineering, IC Bangalore. So today we'll be discussing questions relevant to assignment number 10. So let's start. Okay, so here is the first question. Circular cylindrical vessel closed at the ends is subjected to internal pressure of 0.5 megapascal. If the radius of the cylinder is 300 mm, the longitudinal membrane force N5 will be. So we are given with internal pressure as 0.5 megapascal and radius of the cylinder as 300 mm. We know N5 is given by the relation in the context of cylindrical vessel is PR by 2, which is equal to 0.5 into 300 by 2, and this gives me 150 divided by 275 Newton per mm. So correct answer would be option number B. Now let's solve second question. It's a true and false question. The question is, a spherical vessel is subjected to internal pressure P, then N5 will be half of N theta. So this statement is false, as in this case N5 is equal to N theta, as it is a spherical vessel. Next question. Ellipsoidal shaped heads are commonly used for the end closure of cylindrical cells for steam boilers, reactor and storage vessels. If the major and minor axis of the cell 60 cm and 30 cm respectively, the Gaussian curvature of the cell at the end of major axis will be. Okay, so we are given with 2a. We are given with 2a is equal to 60 cm, which gives me a equal to 30 cm. 2b is equal to 30 cm, which gives b equal to 15 cm. Now at the end of major axis, so principal radii at any point of the ellipsoidal cell at x comma y is given by r1 is equal to a to the power 4 y square plus b to the power 4 x square upon a to the power 4 b to the power 4, and r2 is given the same numerator with denominator as just b square. Okay, so principal radii at the end of major axis will be major axis. So that gives me the coordinate as a comma 0, right? Plus minus a, so that won't make any difference. So r1 would be So x is plus minus a and y is 0, so this gives me b4 a square 3 by 2 on a4 which is b6 a 3 by 2, this gives me 3 a4 b4, so b square by a, and that will be equal to, okay, that would be a, and r2 would be b4 a square 3 by 2 b square, and this would be equal to b6 a cube 1 b square. So this is okay, so I made a mistake here. This is not 3 by 2, this is 1 by 2. So 1 by 2, and this will give me b square a upon b square, so this is a. Now we have the principal radii at the end of major axis. To find the Gaussian curvature, uh, k is equal to 1 upon r1 times 1 upon r2, so times, so this is a upon b square, this is 1 upon a. So 1 by b square, and this gives me 1 upon 15 square. So this would be 44.44 into 10 to the minus 4 centimeter. So correct answer is, sorry, 4.44. 1, 2, 3. This is 4.44.44, and simplifying it, that is 4.44. So answer would be option 3, option C. Okay, let's move on to next question. In a cooling tower in the form of hyperboloid of revolution, in a cooling tower in the form of hyperboloid of revolution of one shade, the vertex of the meridional curve is 10 meters from the vertical axis of revolution. If the distance between two foci is 64 meters, the angle in degrees that the asymptotes to the meridian makes with the axis of revolution is. Okay, so let's first draw the diagram. We are given with a hyperboloid with axis of rotation as this. So here the foci distance is 64 meter and vertex distance is 10 meter from the vertical axis of revolution. So that is we're given with 2c as 64 meter, which gives me c is equal to 32 meter, and a as 10 meter. So with this we'll be able to find b as c square minus a square. So this will be equal to 32 square minus 10 square. So this is equal to 30.397 meter. Okay. Now okay, so we need to find the asymptote angle made by the asymptote. So if we have this asymptote, the angle made by this asymptote phi, if I take this as phi with the axis, we need to find this phi, right? So this is okay, so will be having tan phi as, because this is A and this would be B, so tan phi would be equal to A upon B, and this would be equal to 10 upon 30.397, which would be equal to 0.3289. Tan inverse phi would give me 18, sorry, phi would be equal to tan inverse of 0.3289, which would be equal to 18.2 degree. So if you are rounding it off, it will be equal to 18 degree. So the correct answer is option C, 18. Okay. Now next question. So a conical pressure vessel with slanting side 600 mm is subjected to internal pressure 8 Newton per mm square as shown in the figure above. The vessel is provided with a flat plate of diameter 600 mm to close the opening. The cone angle is 60 degree. So we have this cone angle as 60 degree. The value of circumferential force in theta round at the midpoint of slanting side is. So first of all, I'll just be given with this, right? So let me take this to the next page. So we are given with this as 600 mm, this as 600 mm, and this also has 600 mm. So this shows that, and so this would be an equilateral triangle. So a angle of inclination is 60 degree here also, right? At the this is 600, at this midpoint this would be like 300. Okay, so this would be 300. So if I make this and take this, if I take this is 300, this would be, this was my 60 degree, 30, so this would be 30 degree, right? And this is R2. So at the midpoint of the slant height, R2 is equal to 300 R2 tan 30 is equal to R2 upon 300, right? So R2 is equal to 300 tan 30. Now we know the relation that okay, and at that point R1 is infinity, so we know the relation as n phi by R1 plus n theta by R2 is equal to P, and this will be equal to 0. So currently n theta would be equal to P R2, this would be equal to P into 300 tan 30, and P is equal to 8 Newton per mm square. So 8 into 300 into tan 30, this would be, raise that, this would be equal to 1385.64 Newton per mm. So rounding it off, we'll get 1386 Newton per mm. This is my correct answer. Okay, so next question. In question 5, if the thickness of the cell is 6 mm, the value of sigma phi, that is meridional stress rounded off to nearest integer in MPa at the vessel closure level is. So okay, so at vessel closure level, suppose the pressure P is acting, and we are able to find this n phi, which makes angle 60 degree. And its dimension is 600. So taking equilibrium of force, so we are given with the thickness as 6 mm, right? And we found out the n. Okay, so at this closure level, taking equilibrium, vertical equilibrium, the forces will have n phi sine 60 times, and this is on the circumference, so this would be like 2 pi r and pi d, so pi d would be 600 big times, and this would be balancing the force P times pi d square by 4. So this okay, so n phi would be equal to, if I cancel it, P is 8 Newton per mm square, So 8, so we can cancel 5, can cancel 600. Okay, so we're left with 8 into 600.4 into sine 60. So this will be equal to 1200 upon sine 60, and this is equal to this is also equal to 1385.64 Newton per mm. Now, to find the value of medianal stress, sigma phi, this will be equal to n phi upon h, and that will be 1385.64 divided by 6, which is equal to 230.94 Newton per mm square, or 230.94 MPa. To nearest integer, this would be equal to 231 MPa. So this is my answer. Okay. Now next question. A pressure vessel in the form of circular torus has the following data. Radius of circular cross section R is equal to 100 mm. Distance from the center of cross section of torus from vertical axis of rotation R0 is equal to 300 mm. Internal pressure is 0.5 MPa. We need to find the magnitude of maximum value of n phi in MPa rounded up to second decimal places. So first we need to understand that we are given with a torus. So distance of the radius of circular cross section, this R, this is R, and from here to this is R0. Okay, from the center, like as here, this is R0, this is R. We are given with internal pressure P is equal to 0.5 megapascal. So for a torus, we have n phi. It is given by the relation n phi as P R to R0 plus R sin phi upon 2 R0 plus R sin phi. Okay, so we need to find the magnitude of maximum value of n phi. So to find maximum phi max, need to take the derivative of n phi with respect to phi. So this would be equal to PR, if I take the numerator as so, this would be equal to n phi is equal to 2 R0 plus R sin phi whole square, then this is derivative of the numerator would be p r 2 r naught would cancel, r would remain, and r square, this would be cos phi, minus p r 2 r naught plus r sin phi multiplied with 2 r cos phi. This would be equal to 0, and we can simplify it as the denominator is 0, so this is 2 r naught plus r sin phi times p r square cos phi minus p r 2 r naught plus r sin phi. So I can make 2 p r square cos phi. Equal to 0. Let's so simplifying it to write this again. So we have 2 r naught plus r sin phi p r square cos phi minus 2 p r square 2 r naught plus r sin phi cos phi equal to 0. So simplifying it to r, I can remove p r square 2 throughout. So this is r naught cos phi plus r sin phi cos phi minus 2 r naught cos phi plus r sin phi cos phi equal to 0. So this will get cancelled out, and we have minus r naught cos phi equal to 0, which gives me cos phi is equal to 0, and this gives me phi is equal to 5 by 2. Correct? So this and phi max would be at phi equal to 5 by 2, and that is PR 2 r naught plus r 2 r naught plus r. So we are given with the internal pressure P as 0.5, radius of circular cross section is 100, this is 300, and this is 100. 2 times 300 plus 100, 58, this is 500 times 3 to the 600, 700, 2, 400. So, and it will be like 3500 by 8. And 5 max equal to 437.5 Newton per mm. Okay, this is equal to 50 by 2, so this is equal to 50 by something equal to 43.75 to second decimal place, so this is fine. Okay, let's move on to the next question. Okay, there's a tank, a surface of revolution found by rotating a cubic parabola y equal to kx cube around the vertical axis of rotation as shown in figure. The depth of water is 12 meter and the diameter of parallel of latitude at water surface is also 12 meter. Density of liquid is 10 kilonewton per meter cube. The curvature of meridional curve at x equal to 300 meter rounded up to 2 decimal places in inverse meter is. So okay, so in this question, first we need to find the value of k. We are given at we are given with the equation y equal to kx cube at x equal to 6. We have y equal to 12. So this gives y equal to 12. Sorry. So this gives me 12k 6 cube gives me k as 12 upon 6 cube. That is 1 upon 18. Okay. So we have k equal to 1 upon 18. Now we need to find the curvature of meridional curve at x equal to 3 meter. So we need to find the radius of curvature r1, that is given by, suppose we have fx is equal to kx cube. So f dash x will be 3k x square and f double derivative of x is 6kx. The radius of curvature is found by using this relation. So by 2 denominator have this. So this is equal to 1 plus f dash x would be 3kx square. 3kx square would give me 9k square x to the power 4 3 by 2 divided 6kx. So r1 at x equal to, okay, so at the curvature, sorry, at the point where x is equal to 3 meter, r1 would be 3 would be 1 plus 9k square 3 to the power 4 3 by 2 6k times 3. Okay, and we have k is equal to 1 upon 18, so this would be equal to 1 plus 9k square. K would be 1 upon 18 square 3 to the power 4 3 by 2 6 1 upon 18 into 3 So this would be equal to 9 to the 18, 9 to the 18. Okay, so in the numerator would be having the size of 9 square 80 18 square 3 by 2. So it's 18 this cancel out, so 9 to the 80, this would be 9 by 4 3 by 2 4 9 13 by 4 3 by 2. Just take this. This would be equal to 5.859, and so curvature of meridional curve at x equal to 3 meter would be 1 upon r1, which is 1 upon 5.859. This would be equal to 0.17 meter inverse. Okay, let me write it clearly here. 1.17 meter inverse. So this is my answer. Okay, that's all. I hope everything is clear and easy. Nobody would have any doubt. So, okay, so if you guys have any doubt, just post it in the discussion forum. I'll try to give you answers as soon as possible. Okay, that's all for today. Have a nice day and meet you in the next week.